Hey YouTube. Some of the regular subs on my channel know that I'm into 3D printing as a hobby, and we're going to digress a little bit from our usual bus content and talk about the process of me building this printer, which is a Voron 2.4 R2 from a LDO kit. It took a couple weeks, and I'm not going to do like a full play-by-play on it. I'm just going to talk about my experience and some of the caveats, problems I ran into, and things to watch out for, and general education. So I hope you enjoy. And this is all of the necessary parts, 3D printed parts to assemble a functioning printer. These are the same as what you would get in the Print It Forward program from Voron. I bought these off of an Etsy seller. The quality of these prints, they're printed on a Voron, is very good, very high quality prints. I don't know if you can see that or not, but better than I would be able to produce on my Creality printer, and it was a good buy. So yeah, I would recommend that if you don't have a printer capable of printing ABS. It's a fair amount of filament and time, and the quality of these is quite good. Voron 2.4 R2 350mm build day 4. So why is it day 4 when all I have is a box here? Well, it's not full days, it's a few hours a day, but basically I built this thing the first time and did the diagonal, corner to corner measurements like you're supposed to do, and found that a couple of the corners were about a 32nd of an inch off. That's less than a millimeter, and I thought that wasn't good enough, and so I tore it apart. And I got all my machinist tools out. I got a couple machinist squares, 1, 2, 3 blocks, a digital protractor, which is not machinist grade, but still pretty good for 20 bucks at Home Depot. I just went to town on this thing and got it as good as I could. Torquing the screws down in the blind joints does change things a bit, so you want to get them good and snug. Everything is flush and perfect, and everything as good as it possibly can be. I even downloaded and printed some of these dumb corner things that I saw somebody suggest on Discord. They go into the corner here and help you hold it together. I don't recommend this. This was not as good as what your fingers can tell you. Your fingers can feel like 1/1000th of an inch, right? If something is not flush here, your fingers can tell that. Building it on a piece of countertop that I got from a local countertop supply that told me that they throw away anything smaller than a bathroom vanity. So this was free. And if you get one of these, which you can probably get locally for free in your town as well, you're going to want to take your aluminum extrusions, a few of them, and check it at different angles and see if it's actually flat, because this was not totally flat. And I stuck a business card under one corner of it there because it wasn't flat. They will, it's not as thick as a machinist surface plate would be. So if the table you're setting it on isn't flat or whatever, it will have a little bit of give to it. So tore it apart, put it back together as best as I could. And, you know, perfection is the enemy of good, right? Or the enemy of progress. It is less than 1 millimeter out in 2 corners, but I believe that's good enough. So I'm pressing on, and I've spent enough time trying to make it perfect. And moving on to the next steps in the build. All right, it's day 5 of the LDO build. I've got the bottom on. This is upside down at the moment here. I've got 3 of the 4 motors on. These are pretty cool little mechanisms you build here out of 3D printed parts. I did crack one. I cracked one of the motor mounts tightening down one of these too tight and split that out. So I'm reprinting that right now over on the CR10. So yeah, you kind of got to have a printer in order to build this. Okay, a bit further along on the frame, I've got the idlers installed. And I've built the motors, A and B motors. That go on the gantry. These are the tension adjusters. These are the A and B idlers. They have a tension adjustment on them. Okay, work on the Voron has been progressing. I've got the gantry installed and all the belts installed now. Let's have a closer look. So these are the Z motors, and there's a reduction drive here. There's 4 of them, 1 in each corner. And then there's a small pulley down in there. It's attached to the same shaft as this larger pulley, and that drives the Z's. And then this is a tensioner. It goes over to the carriage. There's a pulley inside here. There's a pulley inside here. The belts stack and go around. And let me flip it around and show you the motors. This is the back of the machine where the motors are. We call them A and B motors. And you can see how the belts run here. The loops around that motor there, and that one there. And those 2 motors working together drive the gantry in the Y-axis, and they drive the carriage in the X-axis. Well, this morning I made the clicky and mounted it in the tool head. This part is attached with a magnet. Okay, I've got 3 different tool head boards here that I'm trying to decide which one to use. This is the one that came with the LDO kit. This is designed to work with Clockwork 1 extruder. This is a new Heartkey Stealthburner PCB that is designed to work with the Stealthburner. And this is a Mellowfly SHT36 CAN bus board that's designed to work with Clockwork 2. And this is designed to work with Clockwork 2. This is designed to work with Clockwork 1 extruder. So, you know, basically the difference on these two is the hole spacing. You see it's just a little bit different there. You know, I wanted to do CAN bus, but you know, I spent probably an hour or two looking this over and thinking about it. And with the LDO kit, I'm going to go with this board. And the reason for that is everything is pre-terminated, even the fans, just to plug right into these connectors. And if I go with either one of these two boards, I'm going to have to re-terminate all the wires that go into these various plugs, because these are slightly smaller than these, than the pre-terminated plugs. So that sucks. Same thing here. So it's going to be less work for me to use this now. And I believe I have a way to make this work with Clockwork 2. So I'm going to go ahead and build the Stealthburner with Clockwork 2 and see if I get this to fit in it. So I'm examining now this Heart K toolhead board and how it's designed to fit in here, as opposed to the stock LDO board. And something that they did with the Heart K board that's nice is these connectors are turned 90 degrees towards the front, so there's more clearance here. And some of these are smaller. So these connectors are a little bit larger and they come straight out this way. So that may be an issue. Well, let's see. Let me just try one here. So we got the part cooling fan. That's this top one. Let's see how this fits. Just temporarily stuff it in here. You get this so the hole lines up right there, one hole. You do something like that. But yeah, it's well, it's pretty tight. So if you need to remove the Stealthburner to get it out of the way, you're not going to be able to access those plugs because of the orientation, you know, to be able to unplug this. Without unscrewing the toolhead board. So I wonder if we go like really close like that. Nope. See, there's just not enough clearance there. I've transitioned over to the printer and installing the extruder onto the X carriage. This is a Clockwork 1 toolhead board. It came with the LDO kit, and I do not think this is really going to work out very well here. I thought there would be a way to have an adapter, something like that, you know, and I could potentially make an adapter to have it set out like set out kind of over here. Wouldn't be able to use the door anymore, right? As the door would hit that, need more room to do that. So I could design a part to do that, but I think I'm just inclined to just run a Clockwork One for now. I think it just might make my life easier. So, gonna build a Clockwork One, stick it on here. All right, here's a shot of the Clockwork One with the LDO toolhead board installed on a Stealthburner. The printer is sitting upside down right now. It seems a little odd. The Clockwork One is a little beefier and heavier than the Clockwork Two. But this is the way to go for the time being for me, just to simplify things. Oh, and the cover for the Afterburner toolhead that works with this board, it will not fit on here with the Stealthburner, so I don't have a cover on it right now. There's probably something out there that I can download and print. I haven't bothered with that yet. Okay, I get the bed installed and I am working on the nozzle end stop. And most people that I've seen doing this, they have the gantry all the way down, and it's hard to see what's going on when the gantry's all the way down here. And so I'm using a machinist square to set that up. And I also used it to tram the bed and get the bed square with the travel of the nozzle, up high like this, just by setting the square on the edge of the bed. I've got it resting on top of the nozzle end stop there. So I need to move the whole thing that way a little bit right now. And it's magnetic because I've got the mag base on the bed here, and so it's nice and grippy. So just a little bit more. Oh, that was too much. And this is at max Y, the carriage is all the way back. Actually, that's probably pretty good right about there. So now I'm going to go ahead and tighten down the position of the stop here. All right, I got all the wires hooked up for now. Smoke test. Gonna power it on, see what happens. I'm gonna unplug the pi. It used to be, oh, it wasn't plugged in anyways. Okay. We're gonna light. Got some blinky stuff going on there. Nothing bad happened. I don't smell anything. Okay, I'm gonna shut it off. It's a good sign. I'll go ahead and plug the pi in, since these are unobtainium now. Go ahead and turn it back on. Pi boots up. Oh, hey, my NeoPixels lit up for a second there. That was unexpected. That was cool. Huh. Okay. Well, it should be connected to my Wi-Fi. Guess I'm going to go ahead and button some things up here and maybe try and talk to it. Okay, I got it buttoned up and I got it talking on my Wi-Fi, so things are looking promising. So probably last look underneath for a while. There's one wire that's too short here. I need to extend. But I need to get it printing so I can print my skirts and fans and stuff here. All right, I've been going through the startup sequences documented in the Clipper manual, and I did find a mistake. I had miswired the Z's on the Octopus board. There's one of the Z's, the very first one, that plug is actually set up for a dual Z printer. And I had inadvertently, gone, Z0, 1, 2, 3, 4 all the way down. And so I'd ultimately ended up tying one of these Z's into the same, the same axis, and everything was off by one the rest of the way down. And so it was screwing up the behavior of this thing. So here's an annoyance that happened because of lack of documentation on the Clicky website, and also following, one of the popular YouTubers' build of this printer. I assembled this Clicky. You have to put this part into the hot end before you put the front on. And I had not installed this part yet. That came later. And you really need to have this one on before you do the hot end build so that you can set this height properly here. So now I can't have this thing come grab the Clicky because of where it is. I need to take this back off. I need to gain access to this and raise it up, which is annoying. Well, it's printing. I'm doing some calibration stuff here, flow calibration. I'm having to reprint another motor mount because that one is cracked. And that's not the first time that's happened. That's a weak point on these. If you use a power tool, you will crack them quite easily. So always do the final tightening by hand, but that one was tightened by hand and it cracked after some use, so that doesn't make me happy. The other thing is I had to move this printer to a more sturdy workbench, even though I have this slab underneath it to kind of weigh it down and provide a flat level surface. I had it on a card table, and I was getting crappy prints because of the vibration from the acceleration of the print head in the gantry. Let me show you. That is what I was getting out of this thing before moving it. Let me show you one of his other parts here. Here's a couple parts just to show you what kind of crap happens when you don't have the printer on a really solid workbench. Now we're getting smooth sidewalls since I moved the printer. So a card table is not going to cut it unless it's a really heavy one. All right, I'm going to talk about something that cost me a couple of hours, maybe so it won't cost you a couple hours. In this webcam text file, when I was trying to get my webcam working, I was having some problems and I thought it wasn't detecting it correctly, and so there's 3 options listed here for which camera is: auto, USB, and RASB. And so I changed this to RASB right here where it says auto, and that didn't work either, and I spent many hours going down a rabbit hole trying to figure out why. And ultimately what I figured out is that there's more than just these 2 options occurring under the hood. When you use auto, it's actually checking a bunch of different ways to talk to the camera, and the RASB method is not actually correctly compiled or included in the fluid pi distribution, or even Raspbian Lite OS or Raspberry Pi OS Lite. So yeah, that changing this to auto immediately got it working. So yeah, that cost me a few hours. Hopefully you don't make the same mistake as me. All right, another mistake that I made in the build that I'll call out in the manual, in the assembly instructions, it tells you to use a thicker, what is this, weather stripping. It's not weather stripping, but this little bit of foam tape that goes along the edge of these panels. You use a thicker one on the side than you do on the top and the back. And I screwed up when I pulled this panel out of the package. I thought it was a side panel because it's almost identical to the side panel. And so I put the side panel thickness of material on it rather than the correct 1mm stuff. I put the fat, it's like 2.5 or 3 millimeters thick foam tape. And so I was concerned that I'm going to run out of this because there's enough, to do the 2 sides. Well, we're going to be able to stretch it and make it happen. So that's good. But watch out for that, right? Just make sure you're using the correct thickness and you've got the right panel before you start applying the material. Like, so take the panel out of the package and hold it up the machine. Make sure you think it is what it is. And then I'm using these really cool snapping latches that I saw on Nero's YouTube stream. I like these quite a bit. Need more of them. So something that was not said in that stream, at least if there was, I didn't catch it, and that is what thickness to print. These come in different thicknesses, and I'm using a 5.5 millimeter thick one in conjunction with the thicker foam tape, and I haven't established the thickness of latch needed for the other thinner panels yet, but it'll probably be like 2 millimeters thinner So make sure when you print these that you're printing the correct amount of latches for the correct thickness foam to go with everything, right? So just a little more thinking stuff to figure out there and watch out for. All right, let's talk about another disappointment with these panels and the foam adhesive. You're going to be seeing this back side of this when you flip it over and you go to mount it on your printer. And this adhesive here, I don't know, man, what this is, if it was, you know, maybe repositioned during installation or what, but you're going to be seeing that and it can look like crap, right? That kind of clear adhesive that they use. You know, it looks like it pulled away during installation or something, and it's yucky there. Doesn't have anything to do with the other issue I was talking about, where we kind of, you know, pulled on it during installation. We kind of, I mean, I wouldn't say stretched it, but you know, you pull it, you know, you're kind of pulling it tight to, you know, to keep it straight. And yeah. So I just found out that the LDO kit does not come with the exhaust fan. It comes with the wire for it that's, you know, got end on it and everything. It's a filter fan. These are the JST XH 2.5 connections. This end is for the octopus board, and then this end is designed to plug into the fan. I did find a GDS timed fan on Amazon that I can get here in a couple days. It's, you know, got to be 24 volt preferably, so we're not mixing voltages. And it's a 60 by 60 fan is required. The build comes with 60 by 60 20 millimeter thick fans. I could not find a 20. That seems like a bit of a special thickness, but I found a 25, and it'll just take longer screws in that spot. It's not, you know, the screw length is not critical there. So the fan I ordered is 5 millimeters thicker, but it'll plug right in. All right, another tip on this LDO printer. Another mistake I made, save you some time. If you avoid making the same mistake I did. I printed the door hinge and handle pieces from the Voron STL library, and after investing a few hours doing that, I realized that LDO has some better ones that are part of their library for the Voron. The hinges are a little more solid because they incorporate a screw for the hinge instead of just being a print-in-place plastic hinge like the Voron library has. And the door handle's got a little place for you to put your serial number. So I had to reprint those, and that's why the front is not on, but I have the 3 sides. And the difference in speed on this printer versus my CR10, which is still on just the first layer here, so it'll speed up. But yeah, I mean, this thing's winning the race big time here. I mean, it's already beyond. There's a full plate of parts that just finished printing. You can hear it crinkling. What I do to speed the cooling process is I'll just use a towel or something and grab this here because it's hot. It's 100°C. Grab it and I'll set it on something cool. Set it on this table, which is cold, and it expedites the part cooling process. You hear that crinkling. This was like a 22-hour print. at Voron speeds. Only this large part here, this one with this thin edge warped a little bit off the bed here, but everything else stayed stuck down really well. And this is fine, usable. You can see it jumping off. It's so funny listening to these things cool. And when they get fully cool, they'll just lift right off, or pop right off, practically. If this one's loose over here now. Oh, not quite. So I want these to cool before I pop them off because the PEI sheets, you're supposed to remove the parts when they're cool. So I think it prolongs the life of the material. All right, let's talk about the exhaust filter for a minute, because I had a hard time figuring out what the right stuff is for this, the filter material that goes in here, and there's only one thing mentioned in the official bill of materials for this on vorondesign.com, and there's really nothing in the instructions about what this exactly is and what to buy. So what this is called on Amazon is a solder filter extractor, solder extractor filter activated carbon filter element. And it's measures 5 1/8 by 5 1/8 by 3/8, and it's roughly takes half a sheet, and you make a stack of these in here. So I'm gonna go ahead and do that. So that's what they look like stuffed in there. The package that I ordered off of Amazon for like $6 is enough to make 2 sets of these to go in here. And yeah, it's a little thicker, but I think that's the idea, right? So you stuff it in there and it makes a nice airtight fit, because the air is going to draw in through the vent here and go through and out the fan here on the bottom, if you choose to turn the fan on. So I think I already mentioned that LDO in their kit, or in their STL files, it supplies some different door handles that are pretty cool. But when you're working with this stuff, you got to refer to the CAD model for Voron to understand how this stuff goes together, because it's not really apparent in the manual. And when you're working with these things, you're going to be flipping them over upside down. And it's really easy to get confused about which way things go when you install them on the doors. And you're putting these magnets in, and you've got to make sure you've got the right polarity on them so they stick together. Also, the LDO, one of these has got a panel on it for your LDO serial number that is not clear when you print it, but you have to peel out the little square, and the serial number thing just snaps in there. And there's how that looks when that just snaps in there nice and flush. I'm covering up my serial because it's used for warranty purposes. All right, here's another mistake I made that was annoying. So the spool holder takes some PTFE tube on both sides of it here to spin on. There's a long section of PTFE tube that comes with the printer, and then there's a short piece Teflon tubing. Now, obviously I saw this and used this in the hot end, but what I should have used the rest of it over here on the spool holder. And I didn't. I cut those pieces off of this, and now this is too short. So, yeah, don't do what I did. Now here's a little something else that some of you may not be aware of if you've not built one of these Voron kits before. They call for a specific brass heatset insert size, M3 by 5 by 4. And the reason is that all of the holes are set up to where these things will just like snap right down in there, right? So the holes on all the STLs, all the printed parts are designed for this size heat set. And they're not always easy to come by. I mean, in the States anyways. So it's something to be aware of. If you're buying a kit, it'll come with them. You won't have to worry about it. But if you're building other stuff ahead of time, or, you know, out of sequence or whatever, be aware. All right, this is another don't do what I did moments on the printer. I've got it laying on its side, and you're looking at the back of it where the exhaust housing is. And installation of this thing is tricky and not well documented in the manual. It gets installed with VHB tape for a portion of it. And then it has a really weird attachment mechanism where it actually has got a couple tabs that go in from the back side here and index the location of another vent on the inside. And that's the vent on the inside. The mistake I made was not fully understanding how this gets indexed in its location before I applied the VHB tape and installed it. And I had to cut the VHB tape away with a utility knife and reposition it after it was installed. So that did not make me very happy to have to do that, but it was okay. It worked out. A good way to understand how that works is, again, to refer to the CAD model, because the drawings are not, or the directions are not clear at all on that. And the other thing that's not addressed at all in the manual is how to wire up the exhaust fan and filament sensor if you're using one. And you know, some people hide them, conceal them inside, conceal them in the 2020 extrusions. I didn't feel like getting that ambitious, so it's on the back side. All right, so here's another one. If you're going to build the Nevermore filter from the LDO kit parts, there's a little green PCB with 6 holes in it that's included in the kit that is not obvious what it is. It's not documented anywhere, but what it's for is to join the 2 fan wires together in the Nevermore and then put the plug on it so that it'll go in the housing here. So yeah, might save you a little bit of wondering. And there's the finished product tucked in there. You know, you got to think about your orientation, right? So I had to solder that up so that I could slide that plug in and have the circuit board come up, you know, and I kind of put it in, you know, I hooked it in there. And then I did leave some excess wire here so that if I have to service these fans, I have some length to pull the wires out from underneath. Yeah, this Nevermore is really a really cool piece of engineering in itself. These parts just slide in here. This lid just slides on. I have to stuff those wires down in there, and then this piece, this is the piece that contains the charcoal filters, pellets, which that's a whole nother subject. Actually, I have some advice on. So yeah, if you read the docs, it says to use non-acid washed carbon pellets or granules, depending on the size of the Nevermore you print, which I printed the big one. It cannot be acid washed because the stuff they use to acid wash the pellets can react with bare metal and cause rust. And that's the most common type of pellet. So was fairly hard to find in stock, and I did find it on Amazon. This is theoretically the right stuff. Use at your own risk. I can put a link in the description if you're interested in that. This is the assembled Nevermore. It's a pretty impressive piece of engineering. And there's fans in there that you trim away. And there's magnets and grill, and there's magnets, and then these, yeah, it just snaps together. It just snaps together with those magnets. Boom. So this is pretty much bone stock LDO motors kit with the mods that the LDO motors kit comes with. We'll get the Nevermore filter here. I am running the exhaust fan on the rear there that a lot of people choose not to run. We've got the click key over here, and I'm running the purge bucket with the brush, and I'm running these really nice clips that are freaking awesome for taking your panels on and off. Of course, I've added a pie cam up there. I got the stock LDO lighting. Running the Stealthburner with Clockwork 1 on here, and the LDO Motors Toolhead board, which, by the way, is practically impossible to get the cover on that. So yeah, that ain't happening. I've got a couple different attempts here that I was just not able to squeeze everything in there with the Stealthburner LEDs and whatnot. There's just not enough room. I'm running the Rapido hotend in here, and I'm running the modified Andrew Ellis perf profile for super slicer at 140 millimeters per second external perimeters, which is the slowest speed. And it goes up from there to 225 millimeters per second for internal perimeters, 400 millimeters per second for sparse infill, and 200 millimeters per second for solid infill. Acceleration parameters have been tuned for this printer, as well as pressure advance tuning and acceleration tuning with the ADS. Is it an ADS 115, or sorry, ADXL Pressure advance and input shaper has been tuned. Input shaper was tuned via the 80XL board attached to the side of the print head there. And then I'll just zoom way in so you can see the print quality. It's quite good for the speeds we're running here.